Hello, hello. Now it's audible. Thank you so much for waiting. So yesterday we have done one work that is an imbalancing concept. So why we have worked on the imbalancing? That is an categorical data when we have right that time we will get in this kind of imbalancing problem. So I will take a today one different example because let's check out about this one. Okay, this one means this one. Even credit card also we have seen. Even we are going to work on now the hard disease data set so that we can get it easily. So what kind of problems and what kind of structures we are having. So hope so everyone is there and you guys are concentrating on this screen as well. And today also we are going to enjoy this session. So many questions definitely will come, but don't worry. I'm trying to solve these questions. Okay. So the first of all, yesterday's point. If suppose if I'm simultaneously execute the yesterday's point as well, no, on the data set, then let's see what will be the solution we'll get here. So I'll data set one I'll use here. So here we have the output, and output is nothing but heart attack. So heart attacks, one is nothing but he has an heart disease, and zero is nothing but he does not have any kind of heart disease. Okay, so I'll check first the data set one of output dot c. So I think yesterday some of the people they said that if suppose this kind of means garbage values of the even Francis sir also you discussed about it that the 40% of data increase, then how can we believe? Now see the 165 and 138 data. So almost how much difference we got here? The 15 and almost 15, 25, 27. Is it correct? This 27 values we are getting a difference in 1 and 0. Is it audible, everyone? Yes. So let me know you guys are there. Then wait. See. The way we have worked on this, the data set one means this is a hard disease data set, and here we have the some input variables means independent variables age, sex, CP, and these are the factors. The name of this means medical related names are there. So the only one thing I got that this is in cholesterol. Okay, so I don't know actually other things as well. So wait, I will go for. If you want detailed name of these columns, so you will get through that heart disease Kaggle data set. Okay, wait, I'll show you actually heart data set. Heart data set do you have? Yes, do you have heart disease data set? See, these are the detailed name of that particular columns. Okay, age, sex, chest pain. So CPI is thing. CP is chest pain, resting blood pressure, and so many things that we have. So okay. See. I think there we have the multiple categories or something. I have to check for that. See here, this person, Rahul, which dataset name it is? The This one is in zero and normal is in one. So zero is normal and fixed defect means that person is having heart problem, and zero is nothing but normal. So I think two isn't reversible. So I think second category we don't have in that, right? Second category we don't have in it. So I'm checking with this. Yeah, only two categories we have are diseases. It depends upon, actually I have only 303, only almost 300 row data, so 14 columns only. So why not we apply on this one and we'll get the difference between that. This is also a probabilistic column, and definitely we'll check, we'll see the consequences of random oversampling, and second one for the major minority, undersampling, oversampling and undersampling. Okay, so what do you think, guys? If suppose if I passing there, so I'll implement this. So instead of typing so much code, why not I copy this code here? Means about this one, about this. Okay, so we can work directly on probabilities. Is it correct? No. See, here I have done in a single cell the splitting and all on. So I'll pass here 2.2% random state is a 9. I have passed x and y, logistic regression, and logistic regression and random state is equals to 0. These are the things that we have now, not an issue. Okay, but say while doing this one, I'm simultaneously side by side I'm checking the accuracy score as well, so that I can get it properly. So accuracy score I will pass here into the second cell, and see uh, the first thing that we have, the all the values are means numerical, so it's good for us to check for numerical values. So here all the rows we have taken, and till last column means second last column, this is maybe THAL, I don't know what it is, so I'll check that THAL where it is. Which column it is. So always we have to understand the CAA, CLP, old pick before this one. So number of major whistle 0 to 3 colored by laws. So I don't know. This is an medical some kind of stuff. Maybe if you guys know about this one, no, please tell me so I can learn so many things here as well. Okay. So let's go for implementation of this. Simultaneously, we can go with this concept of this. Okay. So we'll check about imbalancing. Okay. Oh, sorry. Actually, I have to pass here. 100%. Yeah. So is it possible that we can make it? So you guys are thinking about the how many problems we are getting now to get 99%, means we got in 99% of accuracy, not an issue, means almost 100% of accuracy about our model. But where did you see that problem is there? Means the first thing that we have the imbalancing problem into the 165 and 138, because your data is learning, your data is going to train to the model that is having imbalance, right? That's the factor. First thing, is it correct? No, what I'm telling to you. The first thing, there is a second option as well. Means second problem that we can get, that is cross validation problem. So these are the two factors that in previously we have discussed about it, right? What do you think, guys? Is it possible? Are you getting? Can we move forward so that I can show you more things about it, right? See, there isn't two types, two stages. In that two stages, we are getting the imbalancing problem. Not only taking from the data, taking from the client, and we are getting the imbalancing problem that time. Means not only having in own data set, we are having this problem into the second stage as well. Here also, in this phase also, we are getting this imbalancing concept. So I will show you how we are going to face these problems, imbalancing problem, as well as side by side we are going to check about imbalancing solution. Okay, so first I will implement, yes sir, cross validation technique. Side by side, first we check about it and then we go. Okay, so let's move forward. So yesterday first I will implement this one. Okay, random oversampling, and then we go for that one. I'll take code. So step by step, first, okay, random oversampler, random oversample, okay, and then side by side I will do here. Second, okay, let's go for this one. We have to pass that data on. So let's implement this the way we have x and y. So what is the work of random oversampling? Can anyone tell me what is the random oversampling, so that I can go for the major work? Anyone, you can tell me. Anyone, please. Increase the count in minority. Means those are in the minority, you can increase the count as well. Right. So if I execute this one, no. So let's check out this problem solution. Random oversampler is my class. Okay. Values are increased. Class and R1 is equals to random oversampling. And these two variables I'm taking for the X independent variable and Y dependent variable. And R1 dot fit resample is nothing but your what? This is your method to get a data from X and Y, and that will be increased. That means those are in the the Y is in the major aim is to make a balanced Y data, right? So balanced categorical data, those that present into the Y. So if suppose if I increase the Y column, means if I increase the Y columns data, categorical data, that time simultaneously how much data you have increased of minoritical category, that much observational values, that much independent variables also increased. So if I check the shape of this one, Side by side, I will check the 303 that is in your major original size, and now I'm just passing here size of this one. So x underscore data dot shape. Okay. Oh, wait. So why did I get this bit? Dataset name have to change. Now I got the proper one, that is in 83% because it works on that this one data set. Actually, previously when I executed, no, when made and copy paste, that time that data set we got in properly. So when I made the comments, comment to the data set and data set 2 is that time he get that data set variable. So don't worry, now we are getting the 83.60. So that previously executed means the way you got the percentage, no, that is from credit card for detection dataset, and this one is in hard disease now. Okay, 83. So let's check out the count as well. See, 330. So how much data is increased? About 330 means 28, no? Is it correct? 27 or 28? Maybe 27. Is it correct? So side by side, I'm checking about 330. Why? So I'll check the counters as well. So counters will helps you to show you about the counts, means y data. This is not an actual. This is your after over sampler. After oversample. Now see the size 165, 165 with this. If suppose if I'm using this 165 means I'm using the X data and Y data, definitely you will get to know about the increment of data. Is it correct? No, what I'm saying means you will get to know the accuracy score as well. So can we try to go for the accuracy score? What do you think? Just let me know. Are you getting what I'm doing here? Yes, because that's the main thing. No, if you don't know, if you don't know what I'm doing, then definitely you will get in problem. So better just let me know you guys are getting or not. Okay, so let's go for now. Should we run all again or just accuracy score because we have increased? Just accuracy score. Still, we haven't passed any kind of logistic regression in second after balancing. No, so we'll check for that first, and then we go for. Let's do it. That's why I have made here. That's this whole thing. This logistic regression and all these things. I will show you one interesting fact about it, but don't worry. Okay, now train test split is there, and where I where I have to pass that X data and Y data. Can you tell me where I have to pass? Here, this is correct. Right. So if suppose if I execute this one, no, we'll get to. So I'll use this fact one, one, one. So why I'm changing with the one, already previously we have taken the X values X into the normal execution of logistic regression. So here also I'll change L1, sorry, L2, L2, okay, L2, L2 dot fit, that is in logistic regression. Execute it. So side by side, I will check Yprid as well. Yprid 1, X1. Why? Because X1 I am passing here, no? Check out this one. But I'll make the just X1, okay? And X1 underscore test, that will be here. That is not an logs. This is the L2 of your logistic regression, and LX1 underscore test is in your testing kit, and Y underscore predict 1. See now, sorry, wait. Check out 83.3. 83.3. Previously, how much we got? 83.60. Okay, check out the accuracy that we are getting here. So you guys are thinking about, if suppose accuracy is getting 83.60 and 83.330, 30 around is 30 points difference here we are getting. So why you are getting the 30-point difference? Because you don't have much change. You don't have much difference in your Y data, means Y categories. Multiple your probabilistic categories are there. No, 0 and 1's having only 3 to 27 to 30 counts are there. The imbalancing problem, I'm telling you. Okay, if I'm using this same structure into the credit card fraud detection, there you will get some big difference there. Means suppose 7 to 8 points difference into the prediction, means your accuracy score. Okay, no, don't we change the Y1 test? There is an accuracy where change Y1 test. Slide 9. This one is in your original, no? So don't worry about it. This is an 83 points. This is original. Original means imbalanced problem. So here we have overcome random oversampling, means we have covered balanced here. So see, check out. I will show you one more thing about it, but don't worry. No, we are getting accuracy of new data now. Yeah, here this 83.3. Actually, previously we got an 83.60. Now we got an 83.33, right? Is it correct? Now you got the point. So I'll show you the difference about it. Means about four differences. We should go for the undersampling first, and then we get in the difference there. Okay, first we go there, then. Okay, let's pass the undersampling as well. I'll show you undersampling. random oversampling and undersampling. Okay, see, you have to do only one thing: undersampling. Got it? What you have to do? Undersampling and import random undersampler to save this new data. To save this new data is nothing but where it is means balance data you want to save. Then you go for storing. No, go for two CSV file. Same thing. I got your point, but these are the two different factors. The X data is different, Y data is different. You have to go the concatenate these values and then go for a storage one. But this is an easiest stuff that you can do. Random under sampler. Okay, random under sampler. Okay, so now let's go for implementation of how to create a object. Is this one? Where it is? This one. So I'll create an object here. Sorry. Unknown. So not an it looks like an easier stuff, but the meaning is an huge. And even with random undersampler or random oversampler, we are getting the problems. Means how we can tackle with the problems that we are going to discuss. Okay, so let's go for the implementation of this one. I'll use this concept. See, 138, 138 we got here. Who is in minoritical here? 0. 138 is there. So 165's data we lost and some amount of data, and that comes down into the minoritical counts. So that is in 138. Is it correct? Are you getting a point? See here. Check out once. Check out the content as well. Deleting that data with the help of libraries, it's not a meaning of deleting. In the other hand, you are balancing, but genuinely is deleting. Yeah, his behavior is in deleting, but our major work is in balancing. But it's okay, no problem. We'll go for the checking as well. Okay. Okay, so let's check out side by side. I will show you one major problem that we will get here, and that is means how we can work with that, means cross validation problem where we are getting that randomly deleting. Yes sir, yes sir, randomly deleting. You know what, the way I'm doing, no, the stages are predefined. The way means training, testing, splitting, or if suppose if I'm defining the algorithm, that isn't same, no, is it correct? The defining stages in machine learning, these are the same, so do not get confused about it. If suppose if you know the life cycle of machine learning, you can do any programming easily, but the presence of mind, that is important. Means the way I'm saying, you know, the sense of humor means, if suppose if I'm getting a data in a imbalancing, what I have to do? If suppose imbalancing is really affecting your accuracy or what, if suppose there is a 10 to 15 lines of difference that we get, is that really affecting on your output? If suppose that is not affecting your output, then why to do imbalancing? Are you getting my point? Is it correct? You have to check everything. Means I'm not saying like you just go and just implement the codes and all. If suppose if you're without any, if you are saying that imbalancing is going on, you are directly going to balancing, that is a wrong thing. You have to know about this. Y predict 2 is equals to L3. L3 is my logistic regression. Predict x2 underscore test is nothing but your x2, and this is the file. Yeah, we got it. Okay, so now I'm going to use accuracy here, so you will get to know that. 83.92. Who is into the middle? Who is into the middle? Our original data set, is it correct? Our original accuracy has a middle point, means major ratio he is showing you. See here, he got a near about 83.60. Okay, and this is 83.3, and this is 83.92. Right? Are you getting my point? What I'm trying to say? If you are increasing the count of, if you solve the problem of balancing with the random oversampler, that time your accuracy isn't decreasing. If you use random undersampling, your accuracy is increasing. So this is your model tuning, means you have to change now. You have to change with the test size as well. Check out the test size as well. Means if suppose test size is changing your means accuracy, test size really affecting on it, means model tuning is always important. Are you getting my point? What I'm telling to you? Hello. And not only making this one, I mentioned this yesterday, undersizing will be more accurate. Yeah, actually, undersizing. Now the point is, sir, actually what happened? The total count is in low. Okay. And even if I'm thinking about undersampling, means your minoritical class is having little bit difference. In the yesterday's credit card fraud detection, you are having near about 2 lakh of 2,84,000 your true transactions, and almost 492 is in false transactions. So as comparatively, if I'm thinking about 492 transactions are there, even this is an study material, means study data sets are there. In the real time sector, you will get a huge amount of data set. So that time, the releasing huge amount of data from the data set, that is mostly affecting on the your perception as well, means if your decision making as well, right? Here means more is better. See, more better. I'm not telling you the more better. More better isn't based on your your predictions. If suppose you are passing observational values and you are getting that, you have to check that your output. No, the way I said that you have to create some problem statement, means 3 to 4 problem statement, 5 to 6 problem statement, and check out everything, means check out with the undersampling data set, check out with the original data set, and check out with the oversampler data set as well. Means there we have the 3 models, and on the 3 models you have to pass the 4 problem statement, at least 5 problem statement, and cross verify it is which one is giving a proper way, because you are having a similar kind of accuracy, means almost 30 to 40 points of difference that we have. If suppose this much difference we have, so how can you believe on that model the way you asked now? Yes, is it? So that time you have to check your observational values to pass into the model, check with the checking answers. Is it correct, Rahul? I think it depends on the use case as well. Yes, means the way you are passing into the model as well. Even I will tell you the how much, means how the affecting level is, means going high. See, the way I am discussing, the way we have done the courses this till now, no, these are the things that we have discussed very deeper, right? Not only we are working with the only content, we are working with the consequences as well as the side by side, means as a client purpose as well, right? This is kind of general discussion that is really needed, truly. Write down each time what answers comes and choose. Actually, means I'm not getting actually what it is. Means by changing the test size, random state. Yeah, that is also. So I will add here uh, where I'll pass the note here. Is it okay? Check constant test size and random state. Random state. Okay. Check the independent values, at least 4. Okay. Check with different algos. Check with different algorithms as well, no? So you are working with the only logistic regression, right? If you go for the multiple algorithms and checking with the same independent value. So what do you think, if suppose if I'm applying the multiple algorithms on the same problem statement, this really needs this one? Yes or no? Right? Check the constant test size and random state. Check the independent values, at least 4. Check check with the check with different algorithms with different independent variables, means different independent values, and uh, check the value count. A value count is nothing but after making. Check the value counts after making. See what I'm saying? Check the value count after making. training and splitting data. Is it correct? No, means the note that I have done after over and under sampling concept completion. When you do the under over sampling and original sampling, that time after that you have to do this kind of structure. Make a test size constant, make a random state constant, and apply that. Check the independent variables at least 4 times, means, and check with independent variables. Check the take the 3 to 4 observational values and pass it down there. And different algorithms, when we are going to cover up the algorithm, more algorithms too. And even I will disclose the logistic regression problem statement as well. Even we have to check the counts as well, means training, testing, splitting. So I'll check, I'll pass that one. Wait. You know what? Now check out one interesting fact here. Y test is there, no? So you know that I have made oversampler. Oversampling, that is nothing but you have done the balancing of your data set, means observational values as well as dependent variable as well. So if I pass here Y data, means are you getting something? What I'm trying to say you? What happened here? Can anybody tell me? If you got, say me yes into chat. If you got, if you if you get this point, split size. So we are, you know what happens here? I'm asking to you all guys, what happened here? Is that you are getting any difference here? Is that you are getting any huge problem? Is it correct? No, what I'm saying. What I'm trying to say. Are you getting or not? There we are getting the cross validation problem here. After making the train test split, even making the balanced data set, even making the balanced data set, when we are passing that data into the training testing split, after training testing split also we are getting the imbalance problem. See the screen there. Yes or no? Is it correct what I'm trying to say you? So how can you tackle with that? That is nothing but your cross validation technique. Even we still haven't seen that cross validation techniques, but definitely we'll go for this. Is it correct? No, we have to discuss with it as well. Smooth cross validation techniques. See, after completion of Rahul, see, after doing the balancing data set, you know that 165 and 165 data set we have. So after 165 data, we have passed into that, and 20% of 165 means 165 plus 165. How much it is? 30. 30 means 330. Right. Sorry, 330. So 330 of the 20%. How much it is? 66. Yes, it is 66. 20% of 66. So 66 means you need to slice down your data into 1 as a 33 and 0 as a 32 3. Then your data is getting totally 20% of data. But here what we are getting, ones and zeros count is imbalanced, means your y test also imbalanced, and your checkout y1 train also I'm passing. See here, 137 that is into the 0, 127 that is into 1. So you guys are thinking about, in the both scenarios your model is getting imbalanced. So that time what you do? See, in the model splitting, that time the way you are getting the imbalance, that is nothing but your cross validation technique. And cross validation technique not making any kind of balancing. He is making a trying to reduce the imbalancing problem. Cross validation technique trying to reduce the imbalancing problem into the model, but imbalancing problem is actually making the balancing. Are you getting what I'm trying to say? Cross validation problem statement will not make a balancing. He only try to make a balance, but not an 100% balance. In balancing problem, surely 100% he solved the balancing problem with the imbalancing technique, right? Hope so you guys are working uh, cross validation technique. If we balance this, will accuracy affect? Yes, obviously. So how can you do the balance here? How can you do? See, I'm just asking to you all. Is it necessary to split a data into training set and testing set? Is it necessary to split your data, training set and testing set? What do you think, guys? Yes, if we don't do it, whole data will pass into that. If you make yourself that if suppose your hundreds of count is there, see what I'm saying. If you have hundreds of count, and that hundreds of count yourself, you have done the testing set and training set, what you do? No need to go for the training and splitting. But see, you cannot do yourself randomly separate a data. That's why you are going to do what? Train test split. Because how can you do randomly pick up in a data set, test size or anything? Test size you can do 20% and 80%, but what is the probability that you can make them properly into 20, random state? Is it correct? No. So that's why within a two lines of code you will get in properly splitted data. That's why we are doing that one. So hope so you are getting this point. Yes. So these are the in-balancing technique and cross-validation problem. So in-balancing problem, as actually we can say in-balancing problem as well, and cross-validation problem as well. It works. But the point is that, say, now I'm going to tell you a smooth technique as well. Smooth. Okay. So which technique was best for the hard data or the see this kind of questions, many questions, many times we get in question this one. See, I can't say that the undersampling is good or oversampling is good. Why? Because it depends upon the observational values that who is giving properly answer. Right? If suppose you in the undersampling you're working properly, then you can go with the undersampling. Is it correct? If you're working with the oversampling, your oversampling is always best. Are you getting, sir? Actually, see, this is the first time you are seeing this one. This is the first time you're watching this one, right? But the point is that if you go for the observational values, means exercise with it continuously, and we have to know about the which which means if suppose many of this time, if suppose if you're working with any hospital, and hospital is giving you simultaneously same size of format, means heart disease problem is there, and many of the factors are different in the many hospitals. But sometimes some hospitals are going with the some factors, means some different factors. Some hospitals are working with the some other models. But if you're working with the same client, same problem statement, and every time if they are changing the data, then you used to with that data, you used to with the problem statement as well, you used to with the point of test size and random state as well. So when your exercise, when your problem statement solution working with the same data set, you are believing, you are going to believe on the oversampling, and definitely you go for the oversampling only. It's every time your client is giving you some kind of data, and means some amount of fixed data set, then definitely you will get to know that if suppose if I'm going to use a oversampling here, then definitely it works properly. Why? Because last almost suppose 1 and 2 years of experience you are having into the same data set, then definitely your predictions also believing, means predictions also trustfully, right? Are you getting my point, everyone? Means it's not an one night work. Data science, machine learning is not an one night work. You have to spend your time, you have to spend your daily exercise with it. So which data set is giving properly in the testing set and training set? Is it correct what I'm saying? But what if we combine oversampling and undersampling data? Then we could be more precise in the accuracy. Yeah, that's a good point actually, sir. If I'm going to if I'm going to combine this one, uh, the first thing is you are making duplicate data set data here, right? That's the one factor you have to think about it. Second, in the both cases, you are passing same observational values. The first one, if suppose only if you are going with the oversampling, then you are passing only one same problem statements. So it depends upon us. If I'm making the combination of, it affects on the accuracy, not an issue, because our major target is to train our model. If your model is training duplication of data as well, or your model is learning, suppose different heart disease problem hospitals data, right? If suppose one hospital's data is different, second hospital's data is different, third hospital's data is different, but the observational value count is in same, means there is a thyroid and all the same formation, and every there is an 5 hospitals are there and they are giving same data, means same formatical data. I'm saying, I want to say that. So it major problem is that major discussion about it, your model is learning the data, means your model is learning how much data and how much problem oriented data, means observational values, that depends upon that. The way you go for the small size of data, you go with the combination of data, or you go with the only undersampling data, means small amount of data. It depends upon the observation, it depends upon the solution. Accuracy always changes, always changes. The way previously I said that accuracy is always secondary thing, secondary. Okay, so I'll go for the one more thing here. Okay. Synthetic synthetic minority oversampling. SMOT. Synthetic minority oversampling technique. So you guys are thinking about this is a new point. Yes. So this new point affects dedicatedly and means easily on multi-categorial data set. Means if suppose you are having multi-categorial data and multi-categorial imbalancing problem, that time also this is happens. What do you think, guys? Can we go for this one? So let's say we have used different algos on the one data set, result are different. Now, which one to use? Should we go for the accuracy there or model percentage prediction? Model percent accuracy, see, uh, if suppose the two factors, Rahul. The first one, the observational values and answers, means your actual answers is, if suppose whatever he learns, whatever the model learns, if suppose in that observations I am taking that observations and asking to the model, see, you have learned this you have learned these observations, tell me what is your answer. If suppose he is giving correct answer, then it's good, then you go with that algorithm, go with that model, because same observations you are asking to the different models. The way I said, the accuracy is the secondary thing. You have to check with the accuracy now, means suppose he's giving the both, everyone is giving correct answer, means suppose 5 models you have created. Okay, so 5 models giving correct answers, means If suppose if I'm asking this observation is correct, means this patient is having heart disease or not, everyone is saying yes, 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 yes. Okay, and your accuracy changes. One model is saying 65%, one model is saying 95%, one model is 75. So five models are saying different. So that time, means it's not an like an you are asking one model, means one observation need not to ask one observation. You have to ask near about 4 to 5 observation values to check your accuracy. If suppose after this one, if suppose model is giving a highest number of accuracy, that model is in best now. But when you decide your model is, means which algorithm you have to choose, means which accuracy highest you have to choose, when your observational values, when your test cases are correct, that time how do we create a different models? Different models actually, sir, you have to just pass it down there, different test sizes, right? Make a test size different. If you want to work with the logistic regression, make the test size different, change the random state and create one different module. Are you getting, sir, what I'm trying to say? Want to work with the only logistic regression, you have to change with the test size. If you want to work with the multiple algorithms, if I teach you near about 3 to 4 algorithms and you want to work with the 3 to 4 algorithms, then you have to set a constant test size. You have to set constant test size, constant random state, and apply that whole data set on the different algorithms. Check out the accuracy. The same observational values, not an issue, but change the test size, change the random state, and work on the same algorithms. So every time you have to work on it. Trial and error, trial and error, trial and error. Are there is a different algorithms for the machine learning? How do we change them? Actually, sir, the first thing, the logistic regression we have not an issue. Even we haven't gone through the logistic deeper as well, means logic as well. But logistic is there, KNN is there, and SVM is there, decision tree is there, neobayes is there, random forest is there. So 6 algorithms we are going to learn. When I come to the next session, no, that time we are going to cover up the almost 3 to 4 algorithms in a next two sessions. Why? Because the observational values and the discussion will not complete without multiple algorithms. Is it correct, sir? So now I'll take one more thing from IMB learn dot over underscore sampling import over underscore sampling import trial and error method means actually you have to do exercises, means exercise which changes. Machine learning is an R&D section. Without R&D, and the way I'm executing the problem statement, no, I'm telling you only the steps, but everyone has a different, means mindset, the believing on model, right? Only one point changes, your output is changes. Only test size changes, your output is changes. Means who is a winner in this machine learning? Those are having huge hands-on with the problem statement. The way I'm saying, dedicatedly, whenever you ask any question to me, that time I just think about it little bit and just go for the answer. When I come this kind of structure, when exercise while doing only, right? Hope you got this point. So by doing exercise, we will think everything is okay until we don't know which percentage or accuracy is correct. I think this is everything is done. Yeah, yeah, yes, that is right. I'm telling you, right? Is it correct? No, right? Can we go for the smart here? Can we go for? We'll do more discussion about it, but don't worry about it. Smart, smart. See, I will create here. SM is equals to smart. Okay, and wait, I will pass here. Just a minute. I'm passing same. So see, the synthetic minority oversampling technique is useful for means mostly effective on where in multi-dimension means multi-categorical data set. Okay, so I haven't taken any multi-categorical data set. Wait, I will check that I have taken or not. Actually, wine quality white, that is an actually wait. This is balanced data set. I ever knew. I'll check first. Wait, I will do one thing here. Chest pain types. I'll check for the chest pain. CP dot value counts. See here we have the 142, 87, 50, and 23. Yes. So I would like to go for the CP column for apply smooth. So can we go for it? What do you think, guys? Even I will apply that oversampling as well, but I will go for this one. This is going to be interesting now. Why? Because here we have the multi-category data, and it will be useful to you. So what do you think? Uh, Wait, I will do one thing here. Sorry, Rahul, it will be 143 after smooth, right? Right? Because you are having there no means huge the three categories are there. So 0, 2, 1, and 3. So we are going to increase. The highest one is in 143. So that will be increased there. Not an issue. Wait, I will pass here x1 and y1 because already we have taken. That's why I'm just in changes this one. Data 1. And which count is that? CP. So you know what I'm going to do? Only some columns I will take instead of taking huge amount. Right? 0 to how much it is? 0, 1, 2. This is the second one. So into 13 columns. So you know what actually I have to pass like this. It is CPs and second one will pass. 1, 2, 3, 4, 5, 6. 12. We got it proper all. Is it correct? Last column we haven't taken. See now the prediction we are taking the for the prediction purpose and exercise purpose we are taking chest pain as a Y. Are you getting point? I'm not taking the last column output column for the prediction. I'm taking the chest pain for the prediction. And some of you guys asked me before as well. Can we take middle of the data, middle of the column for the prediction purpose? Yes. Now you will get in this example. Is it correct? See this column we got it. Now x1 has an all data, y1 has an that one column, okay, and this is x1 y1. The randomly means first I'm checking for the original data set, no, without original data set. So I'm changing the variable names because today in the same file we are having same structure, so I'm just passing the prefix kind of stuff. So SM is comes from the smooth, that's why before smooth and after smooth will pass it. So YSM train and XSM test. We got it here. Training purpose SM. Now I'm changing the variable names. Okay, hope you getting this one. For the checking accuracy purpose, you know, we have to go for this one. YSM underscore field. Oh, sorry, actually I have passed here. See, the 52.45 percentage of accuracy we are getting. So what I have done here, hope you guys getting this one. I have passed the multi-categorical date column. Okay, and that column is in prediction purpose, and others are observational values. The x1 and y1 I have taken. The x1 and y1 I have passed into the training and testing set that I have made of four variables for the training as well as the testing one. So testing one that I have passed into the prediction purpose, and I got in that YPRED SM1. YPRED SM1 and YSM test means your Y test, actual Y test that I'm passing into the accuracy score and gotten near about 152. Sorry, 52. So now I'm going to use here the SMOT technique now. After SMOT. Okay. So after SMOT, what we are going to work? So after SMOT, I'll take one thing here. Okay. So this is same, not an issue. You have to change with the x1 and y1. Why? Because these values are same. So that goes into the, I'm just changing sm smooth. I'm taking it smooth. So after this one, no, check out now. Sorry, check out now. Are you getting what I'm trying to say here? What is the work of smooth? What is the work of smooth technique? What is the name of synthetic minority over minority? So what is that? Hello, are you there, everyone? The way I'm just discussing about that, see, the question is that still I haven't worked through the accuracy score, but how much data is increased here? How much data is increased here? Near about the total count is near about one three not three, right? 303, and this is increased near about how much? 143, 143, 143. Near how much it is? So calculation of this one, if I check for YSM dot shape, sorry, 572. Now we have to work on the algos on the new smart data. Yeah, we have to work. We have to work on it. See, now we 572. If suppose the simultaneously if I pass this one, you know what? The x1 and y1 I have passed. No, so here you have to pass which one? YSM data and XSM data. Test size is same. Yes, yes. Test size is same. Lostic. I'll change SM2, SM2, Here I'll change XSM1, XSM1, YSM1, YSM1. Okay. For this purpose, I'm just passing YSM1. What is that? Where? SM2. SM2 is in your logistic regression object. No? YS data.shape. YSM data.shape, that is in your 572 values. After the increasing, after applying the SMOT technique, SMOT is nothing but synthetic. Synthetic is nothing but artificially increasing the data. What I'm saying, artificially. So you guys are thinking about artificially means, artificially is nothing but synthetically means if suppose in Hindi we can say kruthrim or something you can say, right? Should be a 429, should be in 429. Is it correct or not? Linear regression, sir. Linear regression is useful for an implementation for the continuous. No, if you are working with the categorical prediction values, then definitely you can go for the logistic. Yeah, that's 4. Okay, this is correct. Okay, I'm just a little bit confused about that. How he is saying wrong execution, right? So let's go for this one. So YSM1 fit 2, and this is you have to pass the SM2 and predict YSM1. Yes, you have to lot of do. Still we haven't gone through the cross validation techniques, and even we haven't done any extra algorithms. Okay. We'll go for see this one. Matrix accuracy score and accuracy. See, I'll change this accuracy score as well, because accuracy score and one variable. This is one. This is oh sorry. Actually, I have to pass here too, because this one. Now I got the point. Because this prediction values and this prediction. See why I have taken this different variable names, because in the single file we have used 3 techniques and 2 original techniques, means 2 original algorithms, normal algorithms, and 3 means 5 times we have executed and 5 times we have checked the accuracy. So definitely we have to change the variable names and all. So hope so you are getting till now, right? Is it correct? See, your accuracy is increased almost 50. How much that previously? 52 to 63%. Is it true? Now, so now you guys are thinking about how can I believe on that? And same answer I'm going to give you. Check out your observation values. Is it correct? No. The way we are working, the way we are thinking about it. The think about when you go for one more thing, I would like to suggest to you. If suppose everyone is there, I would like to tell you one more thing. Okay. Yes, you guys are there, and some points to be discussed here. The first point, if you are having a binary classification problem, try to go for the oversampling and undersampling. See what I'm saying? If you're having binary classification problem, means binary imbalancing problem, that time you go with the oversampling and undersampling. If you are having multi-classification imbalancing problem, then you should go for the smooth technique. What is the difference between smooth and over and undersampling? You know that over and undersampling can do only increasing, oversampling is nothing but increasing the minority to majority, and your undersampling is decreasing the majoritical data to minoritical data. Is it correct? So what is the difference that smooth is increasing your minoritical data to majoritical synthetically, means he is creating a artificial data into your model, into your data set. So you have to check for that. If you, whenever you pass a small amount of data and check out that he is actually creating an artificial data into your model. Are you getting my point? Is it correct? I know some people are getting stuck in between that how many techniques that we have to learn, because this is your machine learning. It's about same, may one here 50% accuracy. So no, actually we got a different accuracy score, so not an issue. So I'm just thinking about the point about how the data he increased, or which data he increased. Is it correct? Check out. is that is that true that he has created a artificial data into your model? So even we don't know that. Even we haven't checked about this one. Randomly increasing and artificially increasing two different things. Are you getting my point? What I'm telling you? Randomly increasing means randomly same data you are taking from the data set and increasing and making the duplication of data. Randomly removing means randomly taking from the data set and going to remove the data. But artificially increasing in nothing but is there isn't, you don't have any kind of data. He's creating himself the new data. Is it correct? Are you getting a point what I'm trying to say? Everyone, please. Let me know you guys are getting on what the way we have discussed about these points. Little bit tricky to understand, to get the answers. Yes, is it true? See, you have to make a difference in your mind as well. You have to make a difference. Means this is an imbalancing problem. Uh, this is a life cycle of your machine learning. See, if you if you know about a life cycle properly, means stage by stage, slicing the data, training, testing this data, creating model, means model training a data, prediction of model, accuracy score. This is a life cycle top to bottom, and you are making the changes in between that. If you are passing the data, you have to believe on that. Whatever the training you have done, it depends upon your data only. Smart is better for the data, this data. Yes, max to max, your smart is better always. Why? Because he is creating data on the basis of your observational values that present in your data set. Means he is checking all the data set, all the data observations on the basis of he is going to increase. How about if we smooth all columns? I'm not getting route and check them over under sampling. Means smooth means you want to increase the columns duplication of data. Instead of, if suppose if you want to go for the duplication of data, why not you go for the random oversampling? He can do the duplication. He can increase. Smart is solving the problem is that instead of doing the duplication, all data it depends. See, if you want to increase the data, then you can, why not you make a copy paste into the CSV as well. Are you getting my point? Check the count of zeros and increase the observation values as you copy paste. See, many things that we can do easily by your hand only, means easily you can copy and paste it down. But some techniques that we have, and smart is a little bit different. And as comparatively random sampling and oversampling, that thing that we can do here as well. But one thing is that you can pass the random sample count as well, right? Randomly pick up the data. These are the things there, but we can do by hand as well, not an issue. Hope so. See, today in balancing problems that we have covered, no, this is the major stuff when definitely interviewer will ask you. What I'm saying, definitely your interview will ask you while explaining machine learning algorithms. If suppose in the interview some interviewer will ask you about let me know about your project. So whenever you say any project, if suppose suddenly you say the credit card fraud detection I have done, so definitely one question will come, is there any problem you got? Yes, you have to tell them that there I have got imbalancing problem. So imbalance, what type of imbalancing problem? When prediction is there that there is in categories, that categories are imbalanced. So what is the effect? What is the major effect on your model? So you have to tell them model is going to learn bias. Model is going to give the bias answers. So definitely the second question will come, how can you tackle that problem? You have to tell them about there is in three types of imbalancing problems. So I have balanced with the oversampling, undersampling, and smooth. Then I go through that. So once again he will ask you, can you believe on that? You have to tell them, yes sir, because you have to believe. You have to make it that balanced to the understand purpose. Even not only the believing, not only the learning to the model. You have to believe on yourself. No, that I'm teaching proper data. I'm teaching balanced data to the model. So you are satisfied with that one, but you can't satisfy with the model's data slicing, mean train test split. That time also you're going to be imbalancing that time. So two factors are there. Two factors are there, but many times we achieved, right? We have to achieve. We have to reduce some, means suppose if we are getting a 10 problem statements, 10 problems, then we have to solve at least 7 to 8 problems with with the solution whenever I go for the prediction. Please share the interview questions related to the this topic in email. I think I have shared uh, some notes related with that. In that we the important topics also I have added. Hope so you have seen. If suppose I will check as well. So what I have uploaded there. But till then, whatever the things that I have shared, this is majorly I said that this is the interview questions. Imbalancing. What is imbalancing techniques? What is the imbalancing? They definitely ask you. If suppose there is a machine learning interview sessions. Hope so. You will go for that. Yes. So let's go for the next week session. And next week we are starting with the classification problems, means solution algorithms. Until then, you should go for the imbalancing problem solution. Okay. And see you on next week. And thank you so much for that. See you. Thank you. Yes, I will inform to the team as well. Thank you so much.